In this video, we're going to look at fuses and electrical safety for GCSE science. So the first thing that students need to be able to demonstrate is that they know what the circuit symbol for a fuse is. So the circuit symbol for a fuse is this here. It's a box with a line going through it. And this is often a 1-mark question on a GCSE paper. They need to know what fuses are for. So fuses are safety devices. And what happens, they melt if the current gets too high. And why is that? Because a high current, or just any current, but particularly a high current, causes heating. So that's really important. And then it breaks the circuit and stops current flowing, which is then obviously going to protect the circuit. It might protect a component in the circuit from getting an overload, or it might protect a person from touching something that's live. They need to be able to label a fuse in a plug. So you should Google a simple image of a plug, and they should also know typical values of fuses. So typical values are 1 amp, 3 amp, 5 amp, and 13 amp. These are the most common domestic and amounts. Values for fuses. They're not the only values, but they're the ones that are most typically used. Students should then be able to do simple calculations for us in a circuit to be able to work out what is most appropriate. So I won't bother writing out the whole question, but a typical thing might be something like the potential difference is 10 volts, the current is 4 amps, which value of a fuse should be used in a circuit. So they would work out, in this case, really easy. You just simply look at this and you look at the next biggest one. So obviously the next biggest one is 5 amps, so that it provides sufficient current flow, so it doesn't melt, but it's not so high that you could have a large, potentially dangerous current to flow. Usually they wouldn't give you something quite this simple. It would be something like, I know the voltage is 12 volts and the resistance is 6 ohms, which fuse? So now there's a 2-step calculation or 2-step problem. So they first need to work out the current from V over R, so 12 volts over 6 ohms, which would be 2 amps. And then they can look what's the next biggest fuse. The next biggest fuse would be 3 amps. So again, it provides enough capacity for current to flow, but it's not so high that a dangerous current could flow and cause a problem. Equally, they might also give something like a power of 12 watts and a resistance of, a potential difference of 2 volts, and they would also say which fuse, in which case students would need to use power divided by potential difference is current. 12 over 2 would be 6 amps in this case, which would mean we would need a 13 amp fuse. So these two formulas are the ones that are most commonly used with fuses. Students need to then be able to label a plug, like I've already said, with a fuse, but they also then need to be able to label what the different wires are. So in a plug, we've got a blue wire, a brown wire, and then we've got a green and yellow wire. And they need to be able to state the names and also simply the uses. So the neutral wire, which is the wire held at 0 volts, is blue. The live wire, which is going to be the one at 230 volts, is brown. And the earth wire is green and yellow. And again, this earth wire as a safety device. And what does it do? It provides a low resistance return path for the current in case of a fault. So what does this mean, and how is it typically shown? So typically you'll have some appliance, maybe we've got a washing machine, and the washing machine will be earthed. So this is the earth symbol, which is not really something students need to know, but it's worth showing them because it's a life skill as much as anything. And what happens? So maybe there is a fault in the device. So maybe the live wire has become loose and is attached to the metal case, right? Whereas it actually should be attached to the neutral wire after going through the appliance. So now what has happened, the whole of the outer metal case has become live at 230 volts. So if somebody touches it, they would get a shock, and then they would be electrocuted and die because the current would go through them and to the ground. But what does the earth do? The earth has a very, very low resistance, much lower than a person, so that the current will go through the earth to ground instead of the person. So it's a relatively simple concept to explain, but usually requires a couple of repetitions to really get students to appreciate that it's a low resistance path, and current always takes the path of low resistance. So it's not going to bother going through a person with a high resistance when it can go through a metal wire with a couple of ohms of resistance.